Swayam Prabha. Digital India. Educated India.
Welcome to the next lecture on design for modularity. In this lecture, we will try to cover what is module or modules, then modular design, then modularity, design for modularity and design for modularity architecture. So, modular design, a quick recap which we have already seen in the previous lecture. So, modular design is a design technique that can be used to develop complex products using similar components, okay, or we can also write it as simpler subassembly. Okay. It is a design technique that can be used to develop complex products using similar components / simpler subassembly. Modular design can be viewed as the process of producing units that perform discrete function and then connecting the units together to provide a variety of function. So, for example, we take a complete product, we divide the product into several small subassemblies, subassembly 1, subassembly 2, assembly 3 and assembly 4. So, each subassembly has a predefined function. So, what is the advantage? The advantage is going to be if one particular function fails, then replace this alone, rest of the old parts can be retained for their application. So, performing discrete functions and then connecting the units together to provide a variety of functions. Components used in the modular products must have features that enable them to be coupled together to form a complex product. So, first a complex product is taken, that is why even in concurrent engineering stage a design engineer plays a very important role, because when the functional prototype is getting developed itself, it can be distinguishedly classified, okay, this can be one assembly, this can be one assembly, this can be one assembly. Okay. Those of who are finding it difficult to visualize, you take a laptop, in your laptop you have a RAM separately, you have battery separately, you have other hardware separately. So, if the battery conks off, you can replace only the battery. So, this is RAM and let us make this as other hardware. So, you can change whatever is required to meet out your requirements, and second thing is you can also upgrade only the particular element what you want and still the laptop can function as is. So, that is what they say, modular products must have features that enable them to be coupled together to form a complex product. Modular design can be viewed as a process of producing units that perform discrete functions, then connecting the units together to provide a variety of functions. Modular design emphasizes the minimization of interaction between the components, which will enable components to be designed and produced independently. So, I will go back to the same example. Now, what is happening is, since it is established as standards SA1, SA2, SA3 and SA4. These are 4 parts, 4 different parts where it is discretized based on functional use. So, now what is happening is this part alone, so you can manufacture it separately and you can put it in a public domain and say if any industry is interested to produce only this part can compete. So, because of this, what is happening, the performance of this assembly gets enhanced very fast and the cost also slashed down. And when they do that, they also make sure, which enables components to be designed and produced independently. Each component designed for modularity is supposed to support one or more function. Okay. It is not only one function, you can also choose one or more functions. When components are structured together to form a product, they will support a large or a general function, or structured together. Okay, general function. This shows the importance of analyzing the product function and decomposing it into sub functions that can be satisfied by different functional modules. Modules. Modules are structurally independent building block for a large system with well defined interfaces. See, if I go back to the same example, SA1, SA2, SA3 and SA4, you can see here each will have individual functions, and if you start making individual functions, you will again have lot of components. So, now they are also trying to tell you, please integrate with multiple functions as much as possible. The last one is, try to have a proper interface. That means to say, when I dismantle and when I fix it up, it should not involve very complex things, and whenever I try to interface, join, it should give me the best output very fast. They have the following characteristics: module. Okay. They are cooperative subsystem that forms product, manufacturing system and so on. Functional interactions occurs within rather than between modules. Functional interaction occurs within, very important, between modules rather than between modules. So, one function should not be linked here and then here. You can have multiple functions, FA1, FA2, FA3, whatever it is, but all these things should happen and should get interfaced or integrated inside one subassembly. They have one or more well defined functions that can be tested in isolation from the system and are a composite of components of the module. That means to say, when I buy from the market SA2 or SA3, when I test it, it should have his own specification and I should be able to test its specification and the functionality. They are independent and self-contained and can be combined and configured with other modules to achieve the overall function. Modularity can be applied in the areas of product design, design problems, production systems, or in all the three. Modular products are products that fulfill various overall functions through the combination of distinct building blocks or modules, in the sense that the overall function performed by the product can be divided into sub-functions that can be implemented by different modules or components. An important aspect of modular product is the creation of a basic core unit to which different elements can be fitted. For example, if you take a PCB, you can have transistor, you can have resistor, you can have diode, all these things you can have. That is what they say. Modular product is the creation of a basic core unit to which different elements, all these things are different elements which can be fastened or which can be attached to a PCB. You get a complete PCB in the market as a separate module and can be fitted, thus enabling a variety of versions of the same module to be produced. That is why you see the car companies, auto companies, they always say, this is my basic module. Okay. The basic module will have tire, will have all the other engine, everything it will have, and then it will say that the rest all things whatever we do will be an add-on to it. For example, AC will be an add-on unit, speakers will be an add-on unit, power steering will be an add-on unit, and power window adjusting will be an add-on unit, airbags will be an add-on unit, right. So, this is what it is. So, thus enabling a variety of versions of the same module to be produced. So, the car you can produce it at several higher ends whatever you want. So, all those car companies, auto companies, consumer product companies, software, they follow modular concept. Smartphone, they follow modular concept. Apps, they follow modular concepts. Software search engines follow modular concepts. They divide it into two things. One is called as, it is open to all. So, where in which they try to induce the anxiety amongst the users to use their software, and they say if you want to use a slightly higher version, then it becomes paid. So, they are able to clearly distinguish modular and increase the versions. For modularity, design problems can be broken into a set of easy to manage simpler sub problems. So, that is what it is. So, whenever we make a product or when we make a project, we write a objective statement, and this objective statement will be generic in nature, okay, which captures all the key points or the key features of the project. Next, what we do is we divide it into several small milestones. And these milestones will be attached with time frame. So, you can have milestone and then you can have sub milestone. So, what happens is now you have split the entire project into several small sub milestones along with time frames, so that now you can try to solve the problem very easily. Suppose if you have not met out one milestone, then immediately you know what is the mistake which goes around. So, for modularity, it is also follows the same concept. It is broken down into a set of easy to manage simpler sub problems. Sometimes complex problems are reduced into easier sub problems, where a small change in the solution of one sub problem can lead to a change in other sub problem solution. Okay. For example, if I try to change the wheel, the tire, the width of the tire, then the entire performance of the vehicle goes higher or lower. If I take a flatter tire, a tire which has a larger contact area, naturally the mileage is going to go low. So, that is what it is. Sometimes a complex problem can be reduced into easier sub problems when a small change in the solution of one sub problem can lead to a change in other sub problem solution. Should be careful. This means that the decomposition has resulted in functionally dependent sub problems. We should note down this point, functionally dependent sub problems. Okay. So, functionally dependent was the tire example with respect to engine performance I gave. A three-phase methodology can be devised for design for modularity for the development of complex products using modularity concepts. The methodology matches the criteria set by design for assembly and design for manufacturing. So, here we will see the design for modularity architecture. So, the phase 1 is going to be decomposition and design for modularity. So, here in which we will have feature based and variant design. Variant design, so for example, multiple colors which are available in a car. For example, you take a car wherein which the company produces red color, blue color, green color, they are called as variants. Or you can say a standard model, then you have a model which is attached with AC, which is attached with audio system, variants. Okay. Feature based is in the entire car you are dividing it feature based. For example, for cooling we have an air conditioner, for music we have a music system. So, it is a feature. You can change the feature, for example, from X company you can go to Y company, from X watts you can go to Y watts. Okay. So, here audio system is a feature, variants are some small changes. Okay. So, then it will be early cost estimate, rough estimate, it is not going to be perfect estimate, and then you have modular design impact analysis. So, all these things are interconnected, and this feature design is in turn attached with a classification and GT database DB, okay, for modules and product templates. This attached with geometry, functional, physical and material. Okay. These are the classifications which is done based on geometric, on functional, physical and material, because material plays a very important role in the final product. Okay. Then it is a physical form, then functional, then geometry. So, all these things are now coded. This is done coding, codification. They do a codification on this and then they get to this output. Okay. So, here I will have to, you have to pardon me. So, I will put a star here, I will put a star and then I will continue. So, it will go like this and you have furthermore in the block diagram, it is concept, decomposition, then you have modules and sub-modules, interface analysis. So, this continues here. So, all these things put together is phase 1. Okay. So, from modular impact there is a connect to the classification and coding also. Okay. This is phase 1. Let us try to do phase 2. Phase 2 is design for assembly. So, in this design for assembly, we have customer feedback or customer need, then we will have target specification, and then we have generate product concept, and then we have design for assembly rules. This is called as DFA. Okay. So, we have structural decomposition. So, customer needs. So, from target there is a link to DFA. Okay. And from here we get into product concept. Okay. And then from here we get connected to here. So, generate product concept. So, customer need to target, we go back and forth. Okay. So, and then from design for rules, it is attached to the previous phase 1 whatever we saw, to the modular design. If you go to the previous slide, you saw modular design. So, it is this one is attached, DFA rules are attached to modular design impact analysis. Okay. So, now let us see phase 3. Phase 3, you have DFM, design for manufacturing rules, which is in turn linked with cost analysis and this in turn is attached with detailed design and this in turn is attached with prototyping. So, this is nothing but design for manufacturing. So, the design for modularity is divided into 3 zones or 3 phases, phase 1, phase 2 and phase 3. So, some of the major benefits associated with the methodology includes increased design accuracy and efficiency and the reuse of the existing design for the new programs. So, that is what I was trying to explain previously. Library functions for sub-assemblies will be made in the CAD itself, library function. So, for example, in a CAD model, if you see, people will talk about tire separately, nut separately, bolt separately. So, all you have to do is call that nut, call that bolt. So, then the library function is already prefixed for a particular sub-assembly. So, sub-assembly in turn to a function. Okay. So, when you follow modularity, it is easy to call those already existing library functions. So, your product life cycle time goes very fast or it is reduced to a large extent, so rapid manufacturing can happen. So, the reuse of existing design for new programs can be done. Potential for integration of the developed methodology and technology into the engineering design activities is one of the another big benefit. Modular product design and the process of planning the production are integrated in one overall engineering process in which the product features are mapped into their feasible processes in a one-to-one correspondence. This is very, very important. The overall engineering process in which product features are mapped into their feasible processes in a one-to-one correspondence is another big benefit of modularity. In phase 1, design for modularity and classification, we do product and problem decomposition, structural and modular decomposition, associative analysis between the component and the specifications, application of group technology classification technique. So, group technology. Group technology is done majorly from the manufacturing point of view or from the design point of view, where grouping is done based on features or manufacturing, which is similarity, similar features and similar manufacturing. So, that is what is the application of group technology classification systems, which is part of modularity. Construction of the associative measure matrix. Associative measure matrix, what is the relationship between the first and the next, and between one sub-assembly and the next sub-assembly. So, that is what is associative measure matrix. Then optimum module selection. So, these are all part of decomposition analysis which is done when we implement design for modularity or classification. When we try to take a bicycle, I always used to give an automobile, or now I give you an example of a bicycle. It can be divided into 4 or 5 sub-assemblies. One is bike lock, the other one is boom box, the other one is battery, the other one is briefcase. So, these are all modules which can be attached to a bicycle and they can do independent functions. Bike lock can only lock and it has only one function. So, it can lock and the safety is taken care. Boom box is placed there. Battery converts it from manual to electric. Today slowly electric bicycles are coming into existence, manual and electric. That means to say automatic. Battery operated bicycles are there. Then briefcase is a place where it is for storage. So, these are all independent modules which are very similar in shape and size. If you want, you can keep this battery box. If you don't want, you can replace this battery box with a briefcase, wherein which it is going to give you a storage space. Product analysis, designed for assembly and functional analysis, identify the component that could be produced and assembled separately. Next, determine the order of disassembly and assembly for each subcomponent module. Order of disassembly, sequence. Then establish the interfaces based on the analysis of the design feature. Determine the order in which the sub-assemblies are assembled to produce a final part. So, these things will be done in phase 2, wherein which we saw the schematic diagram. So, if you look at it, so this is a product analysis wherein which design for assembly and functionality analysis is done. So, you had a flat plate, then you have so many clips to fasten, then you had washers and other holders, then you had all this fastening agents. So, it is supposed to lock some shaft or something like that. So, this is what is the previous component which is made. Once we use the concept for design for assembly, you can see how much parts have reduced and how the design has become more foolproof. So, you have one side locking and you see number of parts which were here are now integrated into a single part. The single part has multiple features and this can be mounted by using this fasteners, and this is the clip which is there which can be fastened. So, design for assembly and functionality analysis is taken care. The third phase is the design for manufacture, family identification and template retrieval. Family identification and template retrieval is one of the advantage of the doing process analysis. So, family means you try to see whether it is the family can be whether it is prismatic or it is circular, or you can have some other family, for example fastening family, locking family, something like that you can have. So, then what the family identification is done, because in your library function you already have this module there. So, family identification, template retrieval. So, whatever is there you retrieve it. So, that is part of process analysis. Determination of logical order of group technology codes for the process of module. So, basically in group technology, for every part if you see there is a part number. So, this part number may be XXX, YYY, ZZZ and you can have ABC. It follows a system wherein which by looking at the digit part number itself you can quickly find out which group technology family it goes to. Then machine and process calculations can be done. Variant process planning is also part of design for manufacturing, and phase 1 of this methodology is the focus of this chapter. So, phase 1, what is phase 1? We saw decomposition analysis, that is phase 1, that will be covered in full length in this discussion. So, phase 3 is going to be process analysis. We are going to do the specification associated with the phase includes need analysis, requirement analysis. Need analysis is going to be the customer, then requirement analysis, then you have concept analysis and you have concept integration. So, these 4 things are part of phase 3. So, need analysis, then requirement analysis, concept analysis and concept integration. So, this you can see a bracket design which was done before, and now you can see how it is done after. Okay. So, you see that there is a change in the design, there is a change in the design. So, you can see the bracket design is changed such that it helps in fastening. Earlier it was very difficult because we could not hold the part, and now because of this flap which is given, we can hold the part and do the assembly very fast. Okay. So, this is done based on phase 3 analysis, which is part of design for modularity. To recapitulate, what we saw in this particular lecture is what are modules, what is modular design, then defining modularity, what is the design for modularity, how do we execute design for modularity. So, these were the topics which were covered, and then I would like to give a task to students. The task is how do you relate modular concept in manufacturing of shirts and pants. So, what are the different modules which are there when you try to manufacture a shirt and a pant? Okay. And then how do you benefit by doing this modularity? That means to say, if you do not follow modularity, what is the time going to be there, what is the performance going to be there, and what is the cost going to be there, and if you do it, how is it going to be done. When you try to look at a utensil, any utensil at kitchen, see how modularity is followed. Use the concept of modularity and improve the same utensil shape / function. Try to do this exercise for yourself, then you can try to see how this modularity concept benefits in manufacturing. Thank you very much.